Welcome, everyone. My name is Jeff Smith. I'm here with Brian Spendolini. We're both product managers on the database team. We specialize in database tools and platforms, and that includes Oracle REST Data Services, which is usually shortened to ORDS. And I'll probably just be saying ORDS today because I've only got 60 minutes to do about 75 minutes worth of content. I will be going fast. This is almost all slides today. I do have the ability to switch out and live demo stuff if people have questions. If we have time, I'll get to that. Questions should go to the Q&A panel. The recordings can be found. It takes the team about a day or so to finesse the video and upload it back onto the Ask Tom site itself. And if you want to see the slides for this session, you can go to my speaker deck page, or you can just Google that Jeff Smith Masterclass REST slides, and you should get them there too. Actually, let's be polite and put those in the chat. So for everyone, you can find the slides here. We already have a question. Yeah. Okay, so into it. Oh, this is also my contact info, and I do welcome folks to email me if you've got questions, or even more exciting for me, if you want to share some of the cool things that you've built and achieved with ORDS. We're always looking to hear the good stuff. Of course, if you've got bad stuff, if you've got feedback on things that don't work the way you'd like them to, or enhancement requests, I'm happy to take those as well. ORDS is a supported part of the Oracle database, so if you want to open service requests with my Oracle support, you're more than happy to do that as well. And if you're looking for some how-tos based on some of the things you're going to be shown today, then I have examples of all of this on my blog, which is thatjeffsmith.com. So, okay, we already covered all of this. I want to cover just really quickly, because I don't know what the background is for the people with us today. If you're brand new to REST, I want to spend a couple minutes just talking about, what makes an API a RESTful API and why you should care about that, how ORDS works, and then I want to jump into some practical examples of the things that you can achieve with ORDS. And then I'm going to try to tie this into a little bit into what we call the Oracle Converged database, which is the fact that Oracle's not just a relational schema anymore. It's not just tables and views and foreign key constraints. We also have spatial and graph and in-memory and columnar and even JSON document databases. XML DB, of course, has been there for a long time. And the REST APIs you can deploy with ORDS can service all of those data format models and approaches to using Oracle database. And then at the very, very end, if we have even more time, I'll show you, if you're DBAs or if you're in DevOps and you're looking to automate things with ORDS on the database side, so like database lifecycle operations, like cloning or creating PDBs, or maybe you just want to keep an eye on data dictionary performance stats. We'll show you how you can build some cool performance dashboards that are back-ended with APIs that we've built for you and deployed with the product. So you just turn these on and there's like 600 new pieces of information are available to you via curl or any programming interface that can speak HTTPS and understand JSON. So REST is an acronym. It's not a protocol. It's an architectural style. So it's almost always, and I think I can actually say always, it's always combined with HTTP. But just because you see HTTP calls happening does not mean that what's going on is involving this REST pattern or style. And I'm going to skip this one. All right, so what makes the API or the application RESTful? We are talking about, we're going to model objects, so or entities. So think of things in your database that you want to build an API around. We'll use the boring HR schema. So we might build an API around employees. And let's say you want to add a new employee. Your API is going to be all about this employee's entity or object. And then you're going to have a list of HTTP verbs that you can apply to this entity. So your APIs are not going to look like calls to something called add employee or drop employee or change employee or give raise. All of your calls are going to be against this entity called employees, and you're going to be doing things like get, post, put, or delete. And on some of your post calls, you might have some parameters on the requests that give a bit more detail. So if you want to give a raise to an employee, that could be implemented via a post on employees with additional information on the request that says, hey, the change we're looking to make to this class of employees that we want to give everyone a 10% raise because COVID and everyone did a kick-ass job and congrats and spend your money wisely type stuff. We also want to see everything is stateless. And maybe that might be the most important distinction for the API calls into a database where most of us are comfortable with SQLnet or JDBC or what we used to call the old school OCI, which was you have a connection that's continuous, it's stateful, you can do commits and rollbacks, you can continue transactions across multiple calls. In the world of the internet, mobile devices, what have you, everything about what's happening in your application needs to be communicated in every request. So in every request, we're telling the server everything it needs to know to satisfy that request. And so if you're expecting a certain session state, you have to be able to describe that in the request itself. There's no previous session state available for you to piggyback onto. And one of the ways you can accommodate this is taking advantage of links. So in your responses, in your API responses, you're going to communicate next steps to your application or to your users in the form of links. So let's say in that example I started with, I wanted to create an employee. Maybe I do a post to my employees API, and my response, when I say proper response, this would be proper HTTP response. So in the HTTP world, we have these status codes, 200, 201, 301, 302, 400, 404, 401, and then the dreaded 500 class of messages. So that's a proper response for creating something would generally be status 201, which tells the API user, hey, we created something. And then almost just as important, if not more important, is at the end of that response is going to be a link to that employee we just created. And so if you're building a web page, it's very easy to walk the API. You've got a screen where you fill in information to create the employee. You click go, you get a response back from the server that says, hey, we got created. And then there's a little hover bubble or something with the link that you can click. You click on that, and then you're looking at this new employee. So that in a really large nutshell is kind of what we mean by these RESTful APIs. So when I'm doing API peer review for stuff that we're building internally, those are the kinds of things I'm looking for. Are we modeling nouns? Are the actions that we're performing against these things all implemented via these gets, puts, posts, and deletes? Like we shouldn't ever have a get request do anything that changes the entity that we're working with. That should be idempotent. We should be able to call that over and over and over and over and over again without ever changing the status or the state of anything on the server side. Are we communicating what's happening properly via these response codes? And are we using links? And the more exceptions you see to these rules, the less RESTful your API becomes. And it's almost a religion. So, I mean, you can go crazy with this and you can spend hours debating what the exact right code should be or the exact right pattern should be. But if you try to adhere to this, the benefit is as a developer, whether you're working with Mongo, or whether you're working with Active Directory, or whether you're working with OCI, or whether you're working with Amazon's S3, they all have these REST APIs, and they all sort of conform to these rules of the road. And so when you get the ones for your Oracle database and they follow those same rules, it's really easy for you as a developer or for some sort of tech creator to jump in, immediately start playing with it, because you know you can do gets on things and not break stuff. But if you've built your APIs in such a way that that does happen, then you're going to have an unfriendly set of APIs and you're going to be discouraging people from using your system. And we don't want that. So we want to see things like this and not things like this. Like do a get request on, drop employee. That's you'd have to guess what would actually happen here. Like maybe that gets you a list of things that have been dropped. You shouldn't have to guess what's going to happen on these calls. And then for proper responses, in your request, response, in your response header, you'll see these codes and you'll see these messages and you'll see links, and sometimes in the body, or also sometimes in the headers for like a location header, which tells the app where they should go next automatically. Why do we care about this? Maybe one of the best reasons to get into REST APIs for the Oracle database is so we've got a mid-tier involved. We have ORDS running in your web server domain, area, space, whatever. And it's already connected, hooked up with the database itself. And you as an app or automation engineer, consumer, can start interacting directly with the database without ever having to set up an Oracle client, downloading a wallet and configuring SSL. You don't even need database credentials. All you need to be able to do is authenticate yourself with the web server and make requests, these publish APIs, and then you're immediately interacting with things in the database. And that could be with stored procedures in the database. So a lot of us are working with systems that have been around for 15, 20, 30, even 35 years. And there's tons of application logic already built for us in the database in the form of PLSQL. So when we're building modern new apps to hit the data in those systems that have been there for so long, they could be really trivial amounts of code to write, because you're just writing kind of like a skeleton framework of REST APIs on top of all of that existing logic that's already in the database. So when you go to build your web page to create an employee, all that logic in the database that makes sure that the employee's manager exists and that the employee is making an amount of money that falls into the salary range. And you're not writing that as JavaScript code that's going to sit on the mid-tier, or maybe even in your browser. All that code's in the database already. And so when your app makes that request via the REST API and it calls the store procedure, all of the logic checking is already there. And all you have to do is make sure your REST APIs communicate those messages back. So if there's a policy exception, your REST API needs to be implemented in such a way that it returns a 400 level status code that basically, not 400, a 300 levels, no, 400 level status code that basically says, hey, your request was incorrect. And then you provide some sort of information that says, here's how to follow the rules of the road. And pure automation things, if we're talking about a continuous integration delivery scenario where you need to be able to, completely create something from scratch, build up your entire app ecosystem, run a bunch of automation tests, and then destroy it at the end, the database in your apps can go into that system very easily with these REST APIs. So your Docker containers can get created, your Kubernetes clusters can get deployed. And inside of those things, you could be making curl requests to tell ORDS, hey, go create this database, go put this PDB in it, go deploy this schema, go add all this data. And then when it's done, you can make more curl requests to say, drop the whole darn thing, or back it up, or export it off to some sort of session state, or grab all the logs out of it. If you're on the DBA side, if you're wearing a DBA hat, or formerly you're a DBA, now you do a lot of stuff, or you're the sort of person that's a gatekeeper when it comes to the database. When your developers come to you and ask for these sort of things, If you tell them no, they'll generally find a way to go around you to get what they need. So that's when you'll see them, setting up their own private database on their system so they can get their job done. One of our roles or one of our responsibilities is to keep the database safe, but it's also to keep our developers productive. So this is a core part of the database technology now, and provided it's deployed correctly and securely, you can achieve really, really great stuff with it. That's the end of my sell job. Let's get into the real stuff. So if we look at the life cycle of a request, we have a person or a computer or a process or something getting ready to make an HTTP request. And that's what this box right here is. So I'm going to do a GET request on this thing. So this thing, this right here is the entity that's been modeled. So inside the database, this can be broken down into something. And in this case, I have something that looks like a beer. We'll say that one is like an ID column or some sort of discriminating attribute on this entity. And I'm basically asking ORDS to go get this thing for me. The HTTP address basically is saying, well, where is the thing that we're trying to get? So, ORDS can have one database set up with it. It could have 10,000 databases set up with it. And in the Oracle Cloud, we actually do have singular ORDS servicing tens of thousands of databases. So when the request is made, you're basically saying what you want to do with the thing, and you're telling it where the thing is. And then you might apply some optional bits of information, especially when you're doing puts and posts via header parameters, or in the request body itself, there's usually a JSON document with some parameters that might say, hey, this thing that we're getting ready to post, here's how I'm describing that thing. But in this case, it's a GET. It's pretty simple. And the nice thing about GETs is you can generally always do this in a browser. You don't have to use like a REST client like Postman, or you don't have to go down into the command line interface and do a curl. So that request is going to get up into your web tier somewhere. So this is where ORDS is running. So ORDS is a standalone Java program that has its own web server built in. We call that standalone mode, but you can also run it as a Java servlet inside of Tomcat, which is nice because Tomcat's free, very small, very lightweight. Or if you've licensed WebLogic, you can drop ORDS into WebLogic and run it with the rest of some of your Oracle apps, maybe eBiz or Fusion or whatever. But the request gets to the web server. If it sees this ORDS in the servlet space and it goes, oh, this bit of code over here is responsible for this request. And it just says, okay, ORDS, you go take care of this thing that the person's asking for. Well, ORDS has to figure out which database we're going to talk to. It goes into that database, and then it goes, oh, what's in this database that this person wants? Oh, they want item one of this beers entity. I don't know why I'm writing select star from imps. Maybe that's a typo. But anyway, ORDS can translate the REST request into basically the workload or the language that the database itself uses. That's either going to be a SQL statement or some sort of PLSQL block. So anything you can do with SQL, anything you can do with PLSQL in the database, you can implement as a REST API. So basically, I'm saying absolutely anything you can do in Oracle database, you can implement via these REST APIs because we're using the language of the database to do it. So we'll make this request. What comes back in this case is a singular item. In this case, it's a row in a table. We get that result, and then we just print it back as JSON, and we send it back. But we also send it back with the proper status code, the 200 OK. And I left something out. So ORDS has a bunch of connections running into the database, and we call this collection of connections a connection pool. And so as the requests coming in, we go grab connections out of this pool and we use them, we do the work, and then when we're done, we give them back to the pool. So every single request that you do here, let's say I did a request on just beers / which would be give me the entire collection of this thing that I'm calling beers. I don't want just the one. I want all of them. Well, I might have 10,000. But since we're following this REST model, and maybe the request is going to my mobile phone, my app can't handle or doesn't want to display onto the screen a user a scrolling list of my 10,000 items. So what ORDS will do instead is say, hey, our window size here is 25. We're going to get you the first 25 rows. And then if you want more, we'll just print a link to go get the second page or the third page, or a link to get to the last page. Every time you click one of those links, every time you make a request to go get a different item or get to the next page, that's a brand new request. The lifecycle starts over. We get a brand new connection out of the pool. So that's what we mean by this stateless world, and what we mean by you're not having transactions continued across requests. That's probably the biggest thing to get your mind wrapped around if you're a traditional database developer. So the ORDS process itself, if it's running inside a Tomcat, it could look something like this. This is actually an even simplified view of this. What you'll generally see in the real world is a load balancer in front of Apache Tomcat or in front of WebLogic. And that load balancer will actually have 2 to 3, or even, I think in Cloud, Brian, we have some data centers with 10 nodes with ORDS running on it. And it's taking the requests and it's saying, you go here, you go here, you go here, you go here. So between those 10 ORDS nodes, we can handle tremendous amounts of web traffic. And each one of those web servers, whether it be standalones or Tomcats or WebLogics, they all have ORDS sitting in them, and those ORDS are running to one or more databases. So if you're doing Hello World, you're probably going to set it up on a single database. That database could be a container, multi-tenanted database with 100 PDBs in it. It could be a single PDB in that CDB, and you're just connecting it directly to that PDB. Or you could have 50 11 GR2s and 12 101s, whatever, without the multi-tenant stuff on them, and you've got all of those set up. So you're able to deploy ORDS for one or more databases, no problem. And high availability isn't an issue either. So if you've properly set up a load balancer with another region ready to kick in, if something goes wrong with this part of your network, everything can switch over. And then for the databases themselves, if you've set up data guard and you've got your scan listener configured correctly, the database itself can switch all of its workload to the standby databases. So you can literally set up a huge, denial of service test run and try to flood the system with requests. And if you do actually manage to overwhelm the database and it craps out and it fails over to the data guards, your requests will still keep working. The whole infrastructure is able to stand up for that. Sometimes I talk in front of my slides, and in this case I did, which is good because I need to go faster. So about these connection pools, the really thing you need to understand about the connection pools is the default settings for the connection pools probably aren't good enough for any but the most basic hello worlds. So the default size of the connection pool is 10. Everyone wants to know, hey, what's the best size? It's the ultimate it depends answer. And I hate to tell you that, but it's really about how fast is the database code that you have tied to these APIs. Really, the database portion of the request should be running in milliseconds or even faster if possible. If you've got a select statement that takes 30 minutes to run, that is not appropriate for an HTTP request, because you're going to start having pieces of the network timing out. HTTP itself is going to be like, this is never coming back. I'm giving up. Which is why in some points you might have to actually jiggle the way you do things in the database. So if you've got long running things and there's no way for accounting that, you might need to take advantage of advanced queuing and set up messages that you can poll and say, hey, what's the status of that thing that I requested? Or you might actually just build that into the REST API itself. You might say, hey, we know you asked for this thing. Here's your immediate response. Immediately, yes, request accepted. We're doing the work for you. Oh, by the way, here's a link that you can go click and check the status of that thing that you asked for. So you might be doing that kind of stuff. If you've got some long running stuff, maybe it takes 3, 5, 6 seconds to run, and you've got 5 let's say you're a university, and let's say you've got scheduling system for classes. Everyone knows the cool classes fill up first. The seniors know this, and they even get preferential treatment, right? They know they can wait till the last second, sign up, and still get the good classes. But the poor freshmen, they don't know any better. So the sophomores, they'll flood the system the very second the registration period opens up, and you might have 5,000 requests come in all at once. But if each of those requests takes 3 seconds, a connection pool of 100 or even 300 or 500 or even 1,000 is going to be quickly overwhelmed. But I don't have nothing to give you on this. The real world performance team, Toon Kuplars, has some really nice white papers and videos around this. And if you go to the link I shared in the chat with the slides, you can link into those. But if you just Google real world connection pool sizing, you'll find Toon stuff. And by the way, Toon Kuplars, it's spelled like tone. It's pronounced tune. I think I got that right. Anyway, cool guy. The ORDS itself, when you run the installer, you're going to be answering some questions, and then we're going to be spitting out some configuration files. So when you start it up, we read those config files and we know what we're doing. You may need to go change these after the fact. So that could include things like the properties for these connection pools. Starting ORDS up from scratch, you've never done it before. It's going to ask you about 8 questions. It's mostly going to be about the database that we're talking to. And then when it's done, it's going to say, hey, are you ready to start up and run? And you'll say yes. And then you'll have that little web server running on the box that you set it up on. If you want kind of a guided how to do an install, how to get ORDS running, and how to build your first REST API, I've got a YouTube video on my channel that I think it's 22 minutes, but you can watch it at 2x speed and get the gist of it. Everyone wants to know, hey, what goes into the database? So for ORDS to work, we have to know about your database. And once we know about your database, we start to put things inside of it. So the first thing we put inside your database is this user called ORDS public user. That's the user that we use to make those connection pool sessions on. And the second thing we put in there is a schema called ORDS metadata. This is where we put the brains of ORDS. So when you define an API and it's like, hey, this API is this, and behind it is a anonymous block that calls this procedure. That is described as code in tables that are stored in this ORDS metadata schema. So if you're doing an ORDS install, or if you're curious if ORDS has been configured on your database, just go browse the data dictionary. And if you see these two schemas, you know you've got ORDS at one point has been set up to work with the database. When you publish APIs, they get published for a specific schema. And then when they are called, that SQL, that PLSQL workload gets executed as that user. So this is important to know. So your security models, if they've already been set up to tie down a user to have the minimum required privilege sets against stored procedures and the minimum required select and read privs against tables, or if it's using row level filtering or logic there to restrict the data that they can actually see. If the APIs are defined in those schemas, the consumers of your APIs will automatically experience that same protection level as a user that's logged into the database running those queries manually. That also applies to things like resource consumer groups. So if you're worried about someone trying to take down your system by making 10,000 calls to the API, if you have a consumer group set up to say, hey, this user never gets more than 1% CPU, then the API calls that get put in that initiate these sessions doing this work are going to be locked down by those same set of consumer group rules. So installing ORDS on a system, when you're done, there's nothing on that system that can be called unless you've enabled the database REST API module itself. After you've installed ORDS, at that point, you then have to register or publish the APIs that you want ORDS to serve. And we do that by enabling a schema And all that does is it tells ORDS, hey, ORDS, I want you to know about the schema. Maybe it's the HR one. And HR is going to be allowed to publish APIs inside of the schema. And then we're going to be able to satisfy requests on those APIs, and they will get executed as HR. Those APIs could be what we call the auto APIs, where you take a table of you and we enable it, or it could be the code that we're writing, like the selects, the begin, PLSQL call blocks. REST enabling a schema looks like this. I think Brian's chugging through the Q&A. Thanks, Brian. If there are people asking questions why I can't go faster, I don't know. It's a psychological problem I have. I like to talk. So I'm going to try to go faster. There is a public synonym in your database after an ORDS install. There's going to be a thing in there called ORDS. That's a synonym that points to a package in ORDS metadata, also called ORDS. And this is the brains of the ORDS PLSQL API. And one of the procedures in there, or I think this is a function, is called enable schema. And this is where you do the registering of the schemas that are going to have your APIs defined in them. The important things here would be the schema name, obviously, but also this URL mapping pattern. So what that means is if I am going to be calling REST APIs, are going to be ORDS heaps stuff. And please, I'm glad this is being recorded. So when I do a GET request on /ORDS/peeps, ORDS knows that that's actually talking about HR. Now, I'm taking time to talk about this because I think it's important that you probably actually do a version of this. Aliasing the schemas, you're reducing attack vectors on your database. The consumer of the API does not really need to know, probably, that there's an account in the database called HR. So if you call it something like peeps, maybe they can guess that that's HR, but you're not giving them a clue that there's an HR user in the database that they can go try to crack into as the HR user. All right. So after you've enabled a schema, again, still nothing is in the system to be satisfied for requests because you still haven't published any actual endpoints. Once you have a schema enabled, we give you a browser, a web-based app interface to ORDS itself in your database. So I can bring up ORDS /SQL Developer, which we're now calling database actions, but it's SQL Developer Web, basically. And there's a complete ORDS development interface built into this. So I can see what, if my schema is enabled, I can see what the mapping pattern is to that schema, and I can click into that schema and I can see what APIs have been defined, what OAuth 2 clients have been defined, what privileges and roles I have in there to protect my endpoints. And more importantly, I can start building these APIs. So I told you, you've got a couple options. So for a restaurant, you've got your starters, you've got your auto table. I point to a table and I enable it, or I've got my entrees. Maybe I want to go hand write everything and take control of everything myself. The interface in the web allows you to do either of these. You can literally right click on a table and say publish REST APIs, or you can point and click your way through the modules where you're picking the handlers and you're writing the code and you're picking the status codes. The auto REST, completely maintained by us, lots and lots of features. You write zero code, but you also have zero control. You get what we want you to have. So if it just so happens that what we give you is exactly what you need, perfect. I will say that most customers will start with auto REST and they'll get to a point where they have to move beyond that. And they might use a combination of auto REST. They might use some features of it, but not all. But they eventually end up writing their own APIs. There's theories or there's stories out there that this is not supported for production. Auto REST is most definitely supported in production. In the Oracle Cloud, we've got consumers down in Brazil that make millions of these requests a day using these auto REST APIs and achieve really, really cool things with their mobile apps for their consumers in South America. And they didn't have to write any code to get it. It's basically a low code or no code REST API because we're maintaining the SQL and the PLSQL in the backend. For the REST services, this is all your stuff. So they're going to be as brilliant and as awesome and as restful as you code them to be. So if you code them horribly and you don't use right status codes, and you do inserts, updates, and deletes on a GET, yeah, it works. But if you ask me if that's a REST API, I'm going to say, well, it doesn't look like a REST API to me. So you're literally saying what parameters are coming in on the requests, and you're also going to be saying what the output's going to look like. And that output includes the JSON responses, and it includes the status codes and any links. So I've REST enabled a table, employees. I've actually, in this case, I've created a table called fake_imps. I've enabled the table, and you'll see that the ORDS package also has something called enable object, which is similar to enable schema. So I'm telling it what type of object it is. It's a table, the schema that it's in, the actual object we're enabling, and it again has this alias. So I'm being sneaky. I've got a table called fake imps, but it's going to be addressed as imps. So in my browser, when I come up here and do a get on ORDS imps, it's bringing back the rows in that table. So I created a row here for Jeff and a row here for Barry. Barry makes way more money than Jeff. That seems right. And you can see the response comes back. There's an array of documents here. So here's me with the link to my specific record. And here's Barry with a link to his specific record. And the array has some attributes. One of them says has more is false. So this is the entire collection. There is no link to get the next page because there are no more. But there are some other links down here that describe the thing that we're working with. And ORDS is handling all of that coding stuff on the back end for us. All I have to do is tell it about this table. And one way to do that is you can use the API call like I've done here, or you can actually go into multiple interfaces. Apex has this, SQL Developer Desktop has this, SQL Developer Web has this. You right click on the object, you say enable, and it gives you a form to fill out these properties, and you click go and you're good to go. It's much more about than just get, it's full CRUD. So I can get one employee, I can get lots of employees, I can get all of the employees, I can get a selection of employees based on some parameters, like, hey, I only want the employees that have a salary greater than 2,500. I can achieve that with this auto REST API without writing any code. We handle translating those parameters on the query string in the URI to predicates in the SQL string. I can add a new employee, I can change an employee, I can drop an employee, and this one's also cool. I can batch load lots of employees. So here I am adding a single record. So I'm doing a post on the endpoint. You'll notice the address here is still just imps. It's not add imps or new imp or imp/create. It's just imps. It's post on this. In the body of the request is all the information the server needs to fulfill that request. So it's going to add an employee whose name is Miguel, whose ID is 5, whose salary is this big number. The response is, oh, by the way, that thing you just added, we added it for you. Here is the thing we added. Here is a link to that thing. And oh, by the way, your status code is 201. We created the thing you asked. This could also be shown as a curl script, but I find these graphical overviews a little bit easier to understand. I can make a change. So these things are addressed by their IDs. So imps/ the ID points to a specific person. So I can make a change to Mike. I'm saying I want Mike to look like this. Mike looks like this now. Nothing was added, but we did the request. We did the thing that you asked for. It works. So your status is 200, and also here are some links. Delete. Sad. Barry is going away. No, Kenny. I'm getting rid of bad Kenny. So we're going to get rid of this person who's addressed by this thing. and they're gone. So in the response, we actually tell you how many rows we deleted. But if I were to go do a get on this, I'm going to get a 404 because 404 is HTTP for, hey, that thing you're asking for, we can't find it because you just deleted it. Batch load. This is actually the auto feature that the South American customer uses. They are taking on a regular basis a collection of data being collected from the field, which are the mobile apps that their consumers are using, and they're batch loading all of that up into the table. So they're not making a million post requests. They're doing one post request with a million, in this case, CSV payload. And these are getting fed into the table using very similar logic to what we have for SQL Loader. So it's not as fast as SQL Loader, and it's going over HTTP, so it won't be as fast if you're using SQL Plus against the database. But this is much, much faster than doing row by row inserts on the table. I did a performance test. So I'm in the East Coast of the East Coast. I'm on the East Coast of the USA, and my data center is about 400 miles away from me, and I was able to upload 10 million records to an enabled table in less than 25 seconds. So that's 10 million inserts that I batched, had run, and got the output from request to response in less than 25 seconds. Now, can you do that faster, like I said, with SQL Loader or directly on the database? Absolutely, you can do it faster. But doing that much work via curl is fairly reasonable, I think. And I didn't have to write any code for it. I just enabled the table and then exercised the API. Also, it's also properly protected with authentication protocols, which I'm not showing here. But I had to prove who I was to the web server to be allowed to do this stuff. ORDS handles that too. Oh, and there's that thing that I was just talking about. If you're curious what curl looks like, so here's my curl request, curl, here's my stuff, here's the file that I'm posting up, here are my credentials, here's the thing I'm talking to, here's the work that it did, here's the response time. Oh, I lied, I said 25 seconds, I meant 27 seconds. But I made these two requests concurrently. I found that if I did two requests of 5 million at the same time, it actually ran faster than one request of 10 million. I was talking to you about those query parameter strings that we can translate for you. So I don't have to get everything. I can just ask for specific things. So you can build your where clauses into the URI parameter. So I'm saying, I want my employees, and in this case, I only want the employee where the ID is greater than 99. So I've got ID 100, 101, 102, 103. So instead of select star from, I got to select star from where ID greater than 99. If you're using the web interface to enable these objects, we also give you a nice web interface for generating the curl requests that you can use to exercise these API calls. So you can put in the stuff that you want to submit to the API, and we'll actually generate for you the curl command to go make that happen. And you can just copy that out and start playing with it in your Z shell or your command prompt. That's all I'm going to say about auto. Let's get into the modules. So like I said, this is where I think most of you will end up. There's a lot going on in the schematic, but basically your APIs are going to be organized by something we call a module. So every request call will start with, hey, where's ORDS? How's ORDS addressed? What database are we talking to? What schema in that database are we talking to? And then everything after that is either going to be the enabled object or the module name. So I'll create my module, I'll give it a name, that's going to show up here in the address, and then everything after that will be the specific API in that module. So these are stored in a schema and attached to these templates, which is like a pattern that describes the entity that we're modeling. It could be tables, it could be rows in a table, it could be a stored procedure, it could be really anything in the database that you want to abstract out as a thing that you do these verbs on. And then when you actually write the code is going to be my handler is a get, which is the verb, or it's a put, or it's a post, or it's a delete. And then attached to that is the SQL code or the PLSQL code. So again, you're handling everything from the inputs, the outputs, the error handling, what the response looks like. Maybe the response is not a JSON document. Maybe it's a PDF. Maybe it's an animated GIF. Maybe it's CSV. Maybe it's, God forbid, XML. Maybe it's HTML. Well, your code is the one that's producing this stuff. Now, if you want JSON, we'll do the JSON for you, but you can also generate the JSON yourself. You have truly full control over what happens here. So let's say I want to build a module. And again, we're going to use departments and employees just to make it easy to understand. Let's say we want to join information from this. It's as simple as writing your classic select statement. And to keep the new kids happy, yeah, I've used the ANSI style join syntax. So I've got a module called demo. I have a template in that defined as employees/job, that colon job. It's a parameter on the URI. ORDS automatically can see this string and can feed it to the select statement. So I hid the most important thing on this screenshot. Underneath here, there'll be something that says where employees.job equals colon job. And so the response, the data is going to be coming from the results of this select statement. So it looks like when we feed it, ask for shipping clerk. I probably did employee/sh because that's the job code for shipping clerk in the employees table. But it cross-joined over to, not cross-joined, it interjoined over on locations and it interjoined over on jobs to go get the actual job title and to go get the location of that job. Now, we do the paging for you. So like I said, you do have to do all of the work, but we are still doing the basics for you. So if there were 1 million records or 1 million employees, is the resulting from this request, we're still only getting the first 25 for you, and we're doing the windowing and the paging for you and generating the links for you. If for some reason you do want all billion rows at once, you can turn paging off and generate a billion or an array of 1 billion JSON documents. You just have to be willing to wait there for it and hope it doesn't time out and hope it's not too big. Here's the thing that I thought I was hiding for you. Yeah, so employees/job. When you make the GET request, when I say get on employees/gr, this string will get fed directly to down here to this job as a bind parameter. So we're also, this is partly how we're protecting against SQL injection. So as a proper bind variable in the block, you're not going to be able to inject SQL into that. It's only going to come in as a straight up literal that's going to be applied to that predicate as you would expect it to. Here I've got my page size set as 25. Yeah, it's configurable. You can make it 1, you can make it 250, you can make it 25,000, or if you make it 0, that's as many as you want. Yes, you can use cursors. So in this case, I want to do a get on purchasing and get everything inside of purchasing. So you can write that code. So the paging, 0 is no paging. Anything above that, that's how we're breaking up the windowed results of the query. As you jump from page to page, we're running the query again. So if you want consistency across pages, if you're in a highly volatile table and these rows are changing as you page through it, you'll have to build into your query some sort of like flashback or SCN or some sort of period of time that you want to window the stuff. And if that's not going to work for you, then you might want to increase your window sizes so you get more results per page. And you can manipulate what page you're looking at by just using this offset parameter But that's the link that we're generating for you. So you can say, oh, I looked at the first 25, I've got more. The next page, we're just saying, hey, on the next request, you're going to start on row 26 instead of starting on row 1. You can rest enable a view if you want. So if you don't want every column in a table on the auto feature, but you only want specific rows, you don't have to write a module to do this select on just those specific rows. You could also just create the view and enable that if you want, sort of an alternative. I probably stress this too much, but remember, you want to include links whenever possible. Without the links, you're leaving dead ends in your app. So there's very good chance I'm looking at this on my screen and I want to go see something more about Ellen. I want to know Ellen's hire date. It's not there. I want to know Ellen's something else, her address. So I want to be able to click on Ellen. There are no links here, so that's not very friendly. So to generate links, you do that in the select blocks. So when we see an aliased column with this $sign on it, we know to translate that column result as a link. So here are the normal things like their first name, last name, salary, start date, department name, job title, their city. But when it comes to actually city is city and state together, and I'm aliasing that as city state. But when it comes to their employee ID, I'm saying employee ID is going to be a concatenation of imp slash. So that sets up the URI pattern that I want. And I'm going to append to that their primary key record, in this case, employee ID. And I'm going to call this imp record. So here's a link imp record. And when we see that $sign, that's how we know to do that. If I don't have the $sign here, this would not be presented as a link or an array of links. It would just be a flat attribute like everything else. So that's the link trick. When you start building your APIs, what I'll generally do is I almost treat it like a data modeling exercise. Like I want to model the workflow that my API consumers are going to take. It's probably going to be something like, oh, well, they're going to want to create an employee, and then they're going to be able to look at an employee. They're going to want to be able to look at all the employees. They're going to want to look at some employees. They're going to want to do all of these things on employees. So I try to model out what all those templates would be to allow you to walk that path and the verbs that you would need. It's possible oftentimes that I'll write an API that generates a link to something that I haven't built yet. So it's chicken and egg sometimes. Sometimes you'll build the endpoint to get to the thing before you build the endpoint to create the thing. But you want to look for where you've dropped the ball there so you don't have those dead ends. A dead end here would be hey, I've got this thing. I want to go see more information on that. And I go to click that and I get a 404 because I haven't published the API that satisfies that pattern yet. Gets are simple. They're generally going to be select, but they can also be PLSQL. Posts, we're making changes to the system. Those are generally going to be PLSQL blocks. They could be PLSQL blocks that just run selects. They could be PLSQL blocks that run stored procedures that return things, multiple things. They could return ref cursors that we then present as a JSON document. They could return blobs that we then have the system download as the PDF or the MP4. But this is an example of what a post implementation for an API would look like. So I have a PLSQL block. Really, the beauty of ORDS is if you've been working with Oracle for a long time or even just a few years, the code behind your APIs is generally not that complicated. You're writing the same code you're used to already writing. It's just a couple more heuristics for you to get used to. like how these binds map to the parameters, how you manipulate status response codes and the location links. So when you go and create these things, oh, I set my status and oh, here's the location link. I've coded that here. When you're doing posts inputs, you're often going to be attaching to those requests JSON documents, and you're going to have to set the MIME type on your request when you go to do that. In your blocks of code, where you've got first name as a colon as a bind, the implication there is in the post request on peeps. I have a JSON document with an attribute called first name, middle int, last name, title. And ORDS is going to be smart enough to pull those off the request and feed it into your PLSQL block. You can REST enable PLSQL, or you can write your own APIs to call the PLSQL for you. So I've got a PLSQL procedure called iTunes albums that I've enabled as auto PLSQL iTunes. I then do a post to this. I give it what I'm looking for, and out spits out what I wanted. So it's coming back as a ref cursor, or it's smart enough to translate ref cursors as an array of JSON documents. Or you can do this code yourself. Instead of using the auto, you just create a module, and in that module, you've got in this case, a get handler, and that get handler is mapped to this PLSQL block. So I've got a local cursor. I'm opening it for the results of this query, and then I'm returning that cursor in the code. So I'm doing a get on something with the parameter album equal to Thriller, and I'm getting back what looks like a track list of the songs on the Thriller album. This is my personal iTunes library. It was the first tape I ever owned as a person. I want to download a file. This would be the PLSQL block, or this would be the PLSQL that you would run to do that, and you just need to have an ORDS handler set up to do that. So here's the code in the database. Here's the code in the API that's calling the code in the database. And here's me making the request. And saying, hey, here's your file. And I'm giving it the MIME type in the file name. My code is doing that. And then I open it up, and there's my image that I'm storing in the database. Uploading files, also pretty simple. You can attach the contents of a file in your request body. And we have this parameter called body, and it makes it really easy for us to put things in the database. So when I upload this file, I'm telling the database what the file name and the MIME type is. I'm storing that in the table. It gets created. I'm nice. I set the status code, and I give you the location. Makes it easy for me to go get that thing I just added, which is a screenshot of SQL Developer Desktop on my Mac.
So Jeff, we are at the top of the hour.
I'm tired of talking, which is good.
If you wanted to roll over, we could a little bit, but
let's roll over. So I'm just going to say my examples haven't really touched on the different models in the database available, but if you wanted to work with Spatial, or it supports GeoJSON. If you wanted to work with XML, we support XML. You want to work with anything in the database like the JSON documents, we support that as well. If you want to read up more on that, I've got links on that. The API for the JSON documents is called SODA. We've done lots of labs and Ask Tom sessions on that already. Here's what the Spatial looks like. Here's what the XML looks like. Analytics, machine learning, all of that can be done with ORDS. Yes, these can be secured. They're protected with web-based, not database-based roles and privileges. So those are going to be mapped up into your single sign-on, Active Directory based users, as long as they match up the priv and role names and with what you've got set to protect the ORDS APIs are going to be let through. If you try to make a request and you ain't got the right privs, we're going to tell you, hey, you're not allowed. And we're going to ask you to log in with the proper privs. If you need your own security model and you don't have one, you can use our built-in OAuth 2. If you want to use the automated APIs we give you for the database to do all the cool CI/CD stuff, you just turn that on in the installer. And then you've got 500 plus new things you can now do in your database. Again, this is like low code DBA automation stuff. So there's the flag you turn on and you start doing things. These are published in the database docs and also the ORDS docs. Nice thing about these clients, you can suck in the JSON description of the APIs, and then you can immediately start playing with them, assuming you have authentication required. Then you can start building really nice monitoring screens that are being fed. Like, so every grid here is being fed by different API calls that we've built for you. You can do data pump jobs. It's not just about getting things. You can put and post things in the database. Here's a really super nice lab that Brian put together. Modern app dev with ORDS is what you want to look for in the live lab workshop space. Takes about 30 minutes. You don't have a database, you don't have ORDS, no worries. Click this link. We'll set up for you an always free tenancy in the Oracle Cloud. You have your own autonomous database that you can play with, and ORDS is already set up and good to go with you. And when you're done with it, you can just stop using it and we'll turn it off after a while, and a little while later, we'll delete the darn thing, or you can use it forever. It's always free. Here's some additional resources. Our good friend and community leader, Tim Hall, AKA Oracle Base, AKA the person whose articles you read when you Google stuff about Oracle, also loves and uses ORDS. So he's got tons and tons of articles on Oracle Base for ORDS. I've got our stuff. We have the official stuff. Thanks so much, everyone, for your time. 160 of you crazy folks joined us for over an hour. Can't say enough how much we appreciate that. Expect the recording maybe as soon as today, but maybe in a day or two. It's going to be on the Ask Tom site. Brian, did I forget anything?
No. If you want to quickly take a spin through the Q&A answered questions, see if I didn't answer any.
Good point. Here's a good question. Hey, do you have to have two servers, one for the database and one for the app? We really do recommend you don't put your web tier on the same system as the database, because then they're fighting for resources, and if one goes out, you lose both. But no, you can have ORDS running on your laptop and your database running on your laptop. Hey, if there are more, is my iTunes library available on GitHub? No, it's not. I got a lot of my sample data on my website on that Jeff Smith. I can't remember if I shared my iTunes library or not. You might have your own iTunes library. One of the things I like to do is not play with IMP all the time, because IMP is boring. So if you, like, say, have Twitter, you can request your own Twitter information and they'll spit it to you as a JSON document. You can go load that into the table using ORDS, and then you've got all the tweets you ever tweeted as a table. And I have an example of how to do that. You could do the same thing with iTunes. You can export your iTunes library as CSV, and we all know how easy it is to get CSV into a table. There's a lot of open source data sets out there that are fun with. Brian found a nice one called the Trees of Cary. The town that I live in actually has an open data set of the interesting trees in town. He had fun for a few days.
And they want to know your YouTube channel that you mentioned. Is that the developers one, or do you have your own?
It's that Jeff Smith.
Okay.
Yep. Everyone else, thanks for showing up, and we'll see you around on the inner tubes. I think we're doing another one of these soon, Brian.
Yeah, next Wednesday we have one for a developer live event where we're going to walk through the rest enable your database. So we're going to actually be jumping in and using the autonomous database and SQL Developer Web and REST and all that good stuff.
We're actually going to do the stuff that we talked about in the lab.
Exactly.
And I can just sit back and listen to you. So
you don't have to.
That's even better.
Just stay home.
I could be at the beach.
You could be.
Yeah. Ciao, everyone.